as we were talking, I was going to ask how much data could ever be enough for artificial intelligence to be perfect. And I'm asking from what Elon Musk said in one of his presentations, that had it been the world is static, it would have been easier for them to achieve level 5. But because it's a dynamic world, I mean, they will constantly need data. That is one. So how much data do you think is necessary for you to have 100% perfection in artificial intelligence? Now,
wait.
as we were talking,
I think you should put that in context. I think you should put that in context, because you're talking about a specific solution, right, to a specific problem, like maybe self-driving or healing or something.
Self-driving, then most other solutions as well, especially, okay, let's take for instance this COVID-19. COVID-19 has been said to have various species, or what can I say, variant of this virus. There are different ones, and they are saying that what we have in Africa is a subtle one. So the one that doesn't
mutation.
faster like the rest of the world. Are able to take samples from, it's mutating from, all right. So you must be able to take samples from different species of the virus, right? So the same thing applicable to self-driving. You might be flying the road every day, and something could happen that the landmark, which is the building, could have been painted, or it has been demolished, or something. So probably you constantly need data to feed your system to make it perfect. And that is one. Then two is that, okay, with artificial intelligence, image processing is key. Image recognition is key. So what do we say in this system? That is it image recognition and processing the major thing in artificial intelligence? Because I recognize that even if you are trying to do text to speech, you sometimes want to pass some information, or when you want to do optical reading, you want to pass those words as images to the system for it to recognize it and all of that. So what percentage of AI does image recognition or processing takes? Those are the two key questions I want our viewers to have idea of.
Okay, yeah, so to answer the question, the first part about how much data you need to achieve 100% accuracy, the shortest answer is that you never achieve 100% accuracy. And the reason is that human beings don't have 100% accuracy. Human beings are not 100% accurate at driving. Doctors still misdiagnose. People will be surprised if they knew how much low of an accuracy their doctors had in certain scenarios, unfortunately in our part of the world. So complex systems never have 100% accuracy, unless it's something as simple as maybe calculation, where the rule is simple. For that one, if you repeat the rule more than enough, you get the same result. But if you are looking at dynamic, complex scenarios, whether human beings, machines or not, you never have 100% accuracy. So the goal of AI is not necessarily to achieve 100% accuracy. The first goal is that if we look at the best approach today, so if the best approach today happens to be a human expert or classical software that is being used, can you get enough data to train an AI system that performs as well as the current gold standard, or maybe slightly better? So if you can achieve that, then it's good enough to use that AI system. Your goal from there doesn't stop. So periodically, continuously, you'll be collecting not just more data, you also be improving your algorithms so that you improve your AI system for it to keep improving. So if today, let's say, using that small malaria test kits that we use in most parts of West Africa, the accuracy is, say, 80%, right? Let's say it takes 80% accuracy. And then, so 80 times, 8 out of 10 times is correct, 2 out of 10 is wrong. If you can build an AI system that is 85% accurate, then we can deploy that AI system instead of the test kits. 1 year from that, or the next 1 year after you've deployed it, as you are getting more data, you are using it to improve that AI system. After 1 year, your AI system now scores 90%. And then you keep improving it on and on. One interesting thing is that if you ever build an AI system and then you test it on any amount of data and it tells you 100%, you probably don't want to publish that in a scientific paper because you lose all credibility if you do that. So it usually means that you've allowed your AI system to focus too much on issues dealing with other kinds of data. And even if you test your AI system and it's scored 100% on some samples, if you go and collect new kind of data from another part of the world, they'll probably not score 100%. So yeah, as far as data collection, it's a process that you never stop at. You always keep collecting data. Yeah. The second part of, actually, before I move on, there's an interesting finding, which is that if you keep collecting data, right, your AI system will keep improving as you collect more and more data. There's a point that your AI system gets to. If you add more data to it, it actually gets worse. So it gets worse, but then if you keep adding data, it reaches another point, then it starts getting better again. So there's a lot of theoretical attempts to explain why this happens. Why, if you add a lot of data and it gets some point, your AI system, basically, if you're adding data and you get to some point where there are too much data, your AI system might start looking at some random things that are happening in the data and start learning it too, because they've occurred a bunch of times. So there are certain things that might not be realistic, like say, what will be an example? So let's say, for example, if you are looking at chest conditions, people that have pneumonia, you want to detect pneumonia, but then there's a possibility that someone has smaller lungs. So they naturally have smaller lungs, or one of their lungs is slightly smaller than the other one. If you start collecting a lot of data, the chances of this occurring increases. So there might be a number of examples that people have smaller lungs. Your AI system might start to falsely conclude that smaller lungs is strongly associated with pneumonia, even though it might not be the case. But then if you take that step and you still keep collecting more and more data, your AI system gets across that sort of plateau and realize that there might be actually more examples that show that, okay, this is just it's not strongly associated. And more than data also is compute power. So if you keep collecting data, then you need more compute power to be able to process all that data and build your AI system. So that's also another challenge on it. And so that's where maybe companies like Google sometimes have some advantages because they have high cloud compute, maybe startups have. The second part of your question, which had to do with image recognition or just dealing with images in general. Not so. The key aspect of AI today is mainly image and then language, right? Language. It depends on what field you are working in. So in healthcare, for example, yes, image plays a very large role because most of us are focusing on trying to diagnose diseases from medical images. But then if you are dealing with, take for example, translation, if you are in a space where you have to build an AI system to be able to translate languages, then your whole work is focused on languages. And there's a lot of mixture in both aspects. So some people believe that to build, this is purely theory, but if you want to build an AI system that can truly understand human language, right? You need to have a vision as for it. So the logic behind this is that if we are speaking now, and then I make an example and I say, so two cats actually, I have three cats, one is black and one is red. As I'm saying this, there are words where your brain is actually creating pictures of cats and associating the various colors to it. And that is very essential to language and communication. So if someone says something like, I had a very big, or let's say, yes, my trophy, my shoes were big and then my suitcase was small, so it couldn't fit in. If I say that, you obviously know what I mean is that, the shoes are too big to fit into the suitcase, right? But then if you don't have that visual understanding of shoes, suitcase, and if shoes are too big, then obviously they can't. You know that shoes goes into suitcase because you know that this is what a shoe is. This is the object of shoe. Those things are essential to languages. If you have an AI system that is purely just language and doesn't understand the visual concept of this, it wouldn't understand what is supposed to go into what. It understands that you said, yes, the shoe is big and the suitcase is small. But you said it couldn't fit in. What couldn't fit into what? It wouldn't be able to fit. These things are common sense to human beings because there's vision attached to how we process language. So,
how did you get into this space? I mean, how did the Ghanaian boy? What's your AI story?
Sure. Yeah. So I'm quite a radical. At least my beginning was very much radical. So to talk about my beginning in AI, it also needs to include my beginning in computer science and to some degree my deviation away from education. So I've been fortunate enough to be programming computers since age 14. I had a friend who I met and that was the work he did. So he told me that, hey, I build softwares and I thought that was the coolest thing in the world. So he decided to give me some books on it to show me how it works. And that was it. I found my calling. The funny thing is that before that, when people asked me, what do you want to do when you grow up? I told them I wanted to be a banker. I wanted to work at the bank. So had I not probably met him, I'll probably be trying to work at the bank right now. And maybe I would have been working at one of the banks that was shut down by government last year. So it's also, as a deviation, it shows how powerful conversations can be. One interaction, one friendship basically changed
your path.
My whole trajectory. I remember telling my parents that I'm quitting school, I'm not going to school anymore because I already know what I want to do and I know how to become good at it. They've given me the books and everything. And I was a bit university books and I was able to study them. So I said, what's the point of going to a university if I can study a university book on my own? Was very much not fully dedicated. There were certain subjects that I loved, which actually exposed or expanded my worldview. So I was definitely a fan of. If we can talk about African history all day long, I've studied the civilizations from was the Nile empires, not just the Egypt to even was the Mansa Musa of Mali Empire and all those things. I was fascinated by some of these topics. But then for the most part, when I was in senior high school, I just kept practicing my computer science, computer programming skills. I'll go pick up books in the library of old programming languages like Pascal, which are not even used anymore. I just tried to learn it. I was fascinated by this. Right along then, I also came in with, So I also came in contact with AI because reading some of these books, the ideas of AI was reoccurring. And then I remember telling myself that, okay, so I will study computer science and transition towards AI. That was always my goal. I think age 17. So yeah, I think age 17, then I got really serious about AI. So I decided to, not just AI, but I decided to trace back how computer science started. So I note down some major contributions early on. So you have Alan Turing, you have Alonzo Church. These people basically best the whole field, and these are some of the smartest people to ever live, hands down. So I decided to track down their work. Sure, I can argue it because I mean some of the things they were doing was ahead of their time. Like Alan Turing is a monster. Seriously, he helped the British win their war because he was able to decode some encrypted messages and just the kind of things he was thinking about like 70 years ago.
Wait, was it not the one who did I talk about the Enigma device?
Exactly. Exactly. Yes. So that is Alan Turing. It's unfortunate he died under very, very horrible conditions, but some of the things he thought about. So there are certain things that people still call today Turing test. He developed these things decades ago. So he was not only thinking about building AI system, he was even thinking about how do we technically determine if the AI system is truly intelligent. So he was way ahead of his time. So I tracked down, this were originally research papers. So I remember I got a printer and then I just printed like 20 different research papers and I still have most of them today. So I printed them and I tried reading all of them and understanding the math. Fortunately enough for me, I was able to understand a lot of it. There were some that were the math was too big for my head at that time. And so, yeah, but then I got more and more passionate about AI. I also came across what is called automator. So there's a guy called Stephen Wolfram today, and he's very much excited about this automators. I discovered them during that period. Automators are basically, so if you take simple dots on the screen, let's look at it, there are simple dots on the screen. And then if you give it simple rules like, okay, if there are 3 dots together, add 1 more dot to the left. But if there are less than 3 dots, then delete all 2 dots. You can come up with, there are a lot of variation of simple rules. It's the specifics not even about the rule. But then what happens is that if you repeat this process long enough with that rule, basically it's powerful enough to achieve any computable problem or any software program, if you will. Meaning that this, if you are showing a computer graphics of, let's say, a footballer on the screen or something like that, okay. If you can identify the right rule and simple dot on the screen and apply it several times, it will be able to create that. This idea is actually Wolfram, so Stephen Wolfram, who is also one of the very intelligent people. He's also fortunately enough alive today. So he is actually trying to use this to explain the origins of the universe. So he believes that you have a physics background, so I know you'll be very much excited about it. So in terms of to unify special relativity as well as quantum physics, he's trying to do this, but people are using different approaches. There was one string theory and all those things, but he is trying to say that maybe the universe is computable. So almost like the universe is a computer program running. And it started from very, very simple rules. And then if you repeat them long enough, you end up with a universe. So anyway, that's a bit of a deviation. But I discovered all these exciting ideas. Automata is also part of AI. And then I discovered what is now called symbolic AI. I bought a book on how to build symbolic AI using Java and Prolog. It wasn't really exciting. And then I learned a bit of it and then gave up on it. There was also a powerful book that I read, which was, I think it was called 8 Algorithms That Change the Future. So it explains some of the AI systems, image recognitions, explain the AI system that is driving the Google search platform. So yeah, all this helped me become more passionate. What fully drove me into AI was when minoHealth. So I was living in Italy at the time, and I had seen how European countries had very, very good healthcare systems, and it wasn't based on wealth. So poor people had access to quality healthcare, and then you see a hospital exists that those who have money, those who don't have money can, for the most part, all go to the same hospital and get the same quality of healthcare. Very few people go to private hospitals. Then when you compare that to outside of the world where people die because there are not enough beds in hospital and all sorts of crazy problems that are unimaginable from other parts of the world, it became more strong to me that I need to do something about this. So I attempted doing something about this, which was a minoHealth project. So I tried to build a digital solution to address healthcare problems. It didn't take long to realize that if you truly want to solve some key problems in healthcare, you need artificial intelligence. So we don't have enough experts that can diagnose diseases, right? This is a specialty. In all of Ghana, we only have about 35 radiologists. That is not enough. And medical school, or the specialty of being able to build or being able to diagnose diseases or detect diseases from medical images is very complex. So it's not something you can just teach a lot of people. So once I realized that you can actually train or build AI systems that can perform quite as good as humans, I wanted to do that. Is everyone still on the line?
Yeah, we are here. Listen to you. We are here.
Okay. So yes, once that happened, this was in 2015, 2016. I decided, okay, I would. So this is where I specifically got involved in developing neural networks, deep learning system, machine learning. There are a number of frameworks that I learned. So I remember learning keras, which I still use today. Scikit-learn. I was using more of PHP, JavaScript, and those kind of languages back then. I've done Java, but then I realized that Python is more ideal if you want to build deep learning systems. So I got more involved in Python. It was exciting because in reality, it took me about 6 hours to learn how to build my first neural network. Then it took me months to fully understand the full scope of complexities that are involved in neural networks. So building them using something like keras, you can get a high level understanding and build it, run it, and it works. But then if you want to understand some of these processes, I had to revisit algebra, I had to go look at differential calculus, I had to study some of these optimization approaches in math. I had to go study that. And so, yeah, it took some months, but I had already built the AI system, but to get a deeper understanding, I kept studying, and it's a never-ending journey. So I've come a long way since then. It's now we're in 2020, and I've been doing this for 4 or 5 years now. Built a lot of AI system. I think yeah, easily hundreds of AI systems. A lot of them, some of them are deployed, some of them are for all sorts of project research and all that.
It seems that the focus is on AI and health. Also, tell us a bit about your organization, Gudra, minoHealth, AI Life, Runmila. I mean, what are all these, and what's the relationship with all these things?
Yeah. So. Yes, to work in software development. And so I ran some of these projects under my own business. So I think it was called what? I've forgotten the name that was, the name had been changed several times. At one point it was called karaAgro, it was called Eliclim Inc., and all sort of funny names. And yeah, they were all avenues that we used to do businesses for others, either develop softwares or develop websites for them. So minoHealth was where, so minoHealth was where we transitioned to AI. And it was AI applied in healthcare. So minoHealth, the focus is, as already mentioned, that there are certain key problems in healthcare that cannot be solved easily, and AI is a powerful tool to use for that. But not just AI. So you combine AI with technologies like cloud computing, data analytics or data science in general. Even we've been exploring regions like blockchain, IoT, and on. So basically, it's identifying that there are issues in healthcare. How can we use technologies to solve those big problems in healthcare and make it, democratize it, make it available for all? That is very much a key drive for it. So if you have, we want to be able to achieve what Europe has in say, Africa or other developing parts of the world. Can we use AI to make it that people in both our hometowns can have the same quality access to healthcare as someone that is with a lot of money in the US? I am of the strong belief that you can use AI for this. So that is what minoHealth is. Some of the systems that we've developed has to do with using AI to detect chest diseases, so pneumonia, hernia, fibrosis, but also detect cancers like breast cancer. So we have AI systems that can do this. We've been working with health facilities to be able to pilot and test this. We work with EuraCare Advanced Diagnostic Center. They are one of our collaborators and partners. So minoHealth is under Gudra. There are other subsidiaries under Gudra that focus on other things. So one key project that we've been working on is karaAgro, which is using AI to improve agriculture. So there's what is called precision agriculture. And so we've been using AI to do a number of things. We have an app that is in the beta form and it's already available. You can just take a photo of a plant leaf and then the AI system, our app called karaAgro AI, is currently available on the Android store. It can look at the plant leaf and determine if there's any disease present. So yeah, that's one thing we've been doing. And then we have the drone system. And actually during this lockdown, I've been focusing a lot on working on the drone system. So that one is more for bigger farms, being able to do a number of things